Welcome back to part 4 of the Satisfactory tutorial. In this part we're going to be working on actually moving the items along the conveyor belt. So to do that, we're also going to create the buildings base class and a symbol container which will just have some items in it and send them out so that we can test the actual moving along the conveyor belt. So to get started with that, there's a few things I need to do first. First, we're going to have a new input, and let's get into it. The first thing we want, as I just mentioned, is we'll add a new input, and this is specifically for the player character, because to test if our conveyor belt is working as we want, if we were to pick up an item that is moving along the line, we need to inform it to keep moving so it isn't bothered by that. So to do that, we need to be able to pick up an item, which we don't actually have yet. So we're going to do that here. So to get that done, we go into inputs. We can just duplicate deconstruct, and we're going to call it interact. And we're going to be using this interact for almost all the buildings. So open that up, and by default, we should leave it like this. Sorry, so we don't even need to open it actually. We want to open our input mapping context, and we want to add our new input being interact here, and in our case we have F for deconstruct, so we'll use E for interact. So we can leave that here. I'll just move it up so it's next to deconstruct. Save that, and in FPS Satisfactory we call interact IA interact. Now IA interact, we don't have much we need to do. We just want to call our line trace, so line trace from camera again, and we're looking at visibility specifically. Make sure you set this to visibility and not any of the other ones. So if we hit something, we do something, so we'll break out our hit here, and to move forward here we need to actually make something that we don't have yet. So from our hit actor, we want to call does implement interface. So we need to make an interface for that, and we'll add it here. So search under blueprints, and we're looking for blueprint interface. So we're going to call this BPI for blueprint interface underscore, we'll just call it interact because we only have the interaction in here. So open that up, it should look something like this, and we'll call it interact with actor. We want a boolean to return if the interaction was successful, so just call it return value. We can then compile and save. We don't need this anymore. So back in our player character, we want to have our does implement interface and set it to our BPI interact. Do that, connect it to a branch, which will pretty much check if we hit something that accepts this target or accepts the actual function we're going to call here, which is interact with actor. So we just call this here, and on true, well, we're not going to do anything after in this case, we just need it to pick up. So we can compile and save, and we'll need to make one more function here, but before that we need to actually create our items. So let's go ahead and do that. So leave our player open for now, and we'll go into our content browser, and we're actually going to make our new items. So we'll do this inside of blueprints as well. So create a new folder called items. Inside of items, we're going to have another folder which we'll call the data assets. So this is going to be using data assets because that's the easiest way to manage all of this. So we'll start off by searching in blueprints, and we're going to look for primary data asset. Now make sure you select this one. Data asset by itself can't be selected. We want primary data asset. So select that and call it DA for data asset, and we'll call it data asset items. Go ahead and open it, and you should get something like this. Inside of it, we don't need much. We just want a name for our item. It's going to be of type text. We need a static mesh, which will give it its appearance. So search for static mesh. And we're looking specifically for static mesh, not actor or component, just static mesh. Apply that. And the last one, which will be max stack, which will be a type of integer. Now, we don't need to put any default values or anything, but for max stack we will, because it's easier, then we don't have to rewrite it every time. We'll say 100. So that's just the maximum we can have in one spot. So we can close that. We don't need it anymore. And next we can, well, create our items. So with this, what we can do is back in our items area, so outside the data asset, we can right click, search for data assets, or if you want, it's in the miscellaneous folder. Look for data asset, and we want to select our DA items. And what that will do is just create an actual, let's just say an object of sorts for our actual items. So DA underscore, let's say coal for the first one. Now I actually forgot, but we do need to also import our static meshes because currently we don't have what we need. So we'll just call this coal for now, and let's go and import our assets. So inside here in our assets folder, we'll make another one for items as well, so it's easier to sort through them. So let me just go and get those open. Import them in, drag and drop, import all, and we'll end up with 5 items. So in our case, they already have materials, but I'm not going to bother with any materials because this is just trying to do the mechanics more than the actual appearance, obviously. So now we can go back to our actual items. So we have coal here. We can go ahead and open it, and we want to look for coal. Leave it at 100. And what we can do is we can duplicate this and say iron as well. For now, we'll just keep these two. Or maybe we'll change this to iron ore, sorry. And this one to iron ingots. Ingots, there we go. So we just change this to iron ore. So let's just get that. We should have a static mesh for that. And we can open the ingot as well. And we should have that as well. So let's say iron ingots. There we go. So both of these capped at 100, and apparently it did not save the name here. I might forgot to type it. So now we have our 2 actual items. Now remember that for those who don't know, data assets act more as a blueprint, and not in the Unreal Engine sense, but actual blueprint for what an object will be. So alone, they do nothing. They're just a way to avoid using things like data tables and just have things, I think, quicker to access, let's say. So one last thing we need to do here before we move on to making an actual physical, or at least physical in our sense, version of these data assets is we want to make a quick structure. And that structure we'll make in here as well in the data asset, because we're only going to use it once, we won't need to modify it much. So look on the blueprint for structure, and we'll type in st underscore inventory. So the reason we need this is because we want to know how many items we have and what item we're talking about. But at the same time, we need to know what slot they're in, so we can't use a map. So to do that, we want quantity here. So that's an integer. And we also want our item data. And that's going to be of type DA underscore item. So get a reference, object reference to it. And we can save that, so we won't need it anymore. Now, the next thing is we need our physical item, as I said before. So that's going to go into blueprints rather than in our items. So we're going to create a new blueprint class of type actor, and it's going to be a underscore item. So now that we've made that, we can actually go back into our first person character here, and we want to create a new function we'll call pickup item. Now pickup item, we're not going to do anything because we haven't set up anything, but if ever we do in the future, we have it set up here and is ready to use. So it's going to be of type, well, this is going to be the new item, let's say, of type, this time a underscore item, not because we're talking specifically about an actor class, not a data asset. to make sure it's specifically the A one. Then we can compile and save, and we no longer need our FPS Satisfactory. So next is, as we said, the actual item. So for the item, we can open it here, and we'll bring it in here. So for the item, we have quite a bit to do, but we're going to start by making all our assets, etc. First thing we need is a well, actually, first we need to add our blueprint interface that we made. So inside of our class settings, we're going to go down to interfaces, and we want to add the BPI interact. What this will do is it will create a new category here with your actual interfaces, and we can open it up and have it do anything once we call the actual actor function from our player when we hit it with a line trace. So the first thing we want to do is we'll actually add our static mesh, because we want to have a visual appearance to our actual items, right? So for this, what we'll do is we'll test with a piece of coal, let's say. So let's add our static mesh for coal. And one thing we can do here is, due to how I've made my conveyor belts up until now, there's a 10 value, let's say, in between where the pivot is and where the actual top of the conveyor belt is. So we can keep the scene root instead of doing this and set this to 10, which means it will actually be floating if you place it on the ground, but in the case of our conveyor belt, it will be set to right above the conveyor belt, instead of having to tell when we move it to be 10 units above and breaking the transform, which is a bit more annoying. For the collisions here, we want to go and make them custom as well. We want it to ignore everything except visibility. That way, if we're testing whether a conveyor can be built and there's another, there's, for instance, let's say a piece of iron on a conveyor belt in front of it, then it won't cause any issues with the general, which is the detection for collision. Let's get to our variables now. So for the first variable, we need our data asset. We need to know which one we're actually talking about. So we'll call it data asset, very simply, and it'll be of type DA items. So object reference again. We want this to be exposed on spawn, so make sure you check instance editable as well. We're going to duplicate, because we need 3 of these, or at least 3 exposed on spawn. We need a conveyor reference. So this is the reference to the conveyor we're currently on. So a_build, and we're looking for the conveyor. Next, we need a reference to the item interval. So this is the distance we want to have between each item when it spawns. So this is something we're going to set up in the actual building space, because the items always, to get on a conveyor, need to go through a building. So we're just going to set a base value for all the buildings, and that's what will be used to apply to all our items. So this needs to be a float, and that does it for our exposed variables. Next we have item in front, and this is a reference to the item that is moving in front in the conveyor. We have this so that if ever an item in front stops or gets too close, we stop the one behind, this current one, and that's kind of how the whole logic works, more or less. What we'll be doing is we'll be telling which one's in front if we remove it, if we pause it, if we add a new chain, etc. So we're going to say this is of type A items. So, sorry, A item. Make sure it's the A, not DA. Make sure we don't need this one exposed on spawn, so we can leave it as is. Next, we want a boolean called has reached end. Boolean. And one last variable we'll be calling alpha, which is going to be how far we've progressed along a conveyor belt. In the case of alpha, we can keep it private. It's never going to be used outside of this actual code. Next is the last piece of our variables slash, not exactly, it's an event dispatcher. We're going to need 3 of these. First will be called TL stopped. The second will be called, well, sorry, we can't duplicate these. TL started. And finally, a last one called spawn next. Now, individually, what these do is they allow us to refer to another function, to call another function, let's say, outside of our actual code here. What this is for mainly is when we spawn them, once we reach a certain point, for instance, we'll call spawn next, which will tell our building to spawn the actual next item. Started will do the same if we have an item that is paused, that is stopped because for whatever reason. It will inform once it can start moving again, it will inform the one behind it that it can also start moving as well. And the opposite obviously happens for stopped. If it stops, it will inform the one behind it that it needs to stop as well, if it reaches at least the point in front of it. Next, we can get into our event graph, which is where everything is going to happen. So the first thing in event graph is we don't need the tick, we don't need the event begin overlap, we just need begin play. We're going to start off by checking if we have a reference to the conveyor belt, because if we don't, then none of this actually runs, so we'll just not do anything. We'll start with a sequence, and here we're going to have a new function that we don't have yet, so we're going to have to go a bit back and forth. Same here, we'll need another function that we need to make, and some timelines. So let's get to those first. We'll do everything we can in here and then move on. So we're going to start with a timeline. So search for add timeline, and we'll call it TL_movement. The TL_movement, we want it to be 10 seconds long. We want it to have one float track, which we'll call alpha, and it will go from 0 all the way to 1 at 10 seconds, value of 1. We can then press F to focus all of them, and we can close it. Don't need this yet, we'll go into that a bit after. So obviously alpha is going to be set alpha, the value that we made earlier, which you can then apply right here. We then want to check if we have an item in front, because if we have an item in front, we need to start checking whether distance-wise we need to stop or not. So first we're going to avoid the isValid, because for the isValid we need to make a few functions that we don't have yet, so we'll just leave this here for now. Now add some reroutes just so that we know where we're going, and add another one here. If this is false, we'll be continuing along this row. So next we need a branch, and for the branch we're going to make our boolean here later, or I think, no, we need some more functions first. What we'll call at the end here though is set actor transform, and it's going to be based on our alpha that we set here in the transform of the actual spline. On the other hand here, what this is pretty much is it's going to be a check whether we are already at the end of the conveyor, because sometimes due to how it works with floats, it will sometimes not actually be properly at the end when it calls finished. So we just want to check that if it reaches the end, we'll stop it anyway. So next we need a few more functions. One we'll call custom event, we'll say CE stop movement. And as the name indicates, it's just going to stop this timeline once we call it. So we'll actually need a function here, right here, that we're going to call, and we're going to reroute. And this function is going to be called, so collapse the function here, condition to stop. And this can be a pure cast. And this is actually going to be used also right here. It's going to go there. So if the condition to stop is met, then we'll call this here. Here we actually have a branch because we can call this from different areas, but we also want a custom event here called CE force stop, which we'll be calling as well, but it avoids us having the extra call of this check that we don't need. So sequence, if the condition is to stop, true, then we stop and we go through the sequence, and we'll call our timeline stopped here. So this will tell our one behind to actually stop. And because what we'll be doing is assigning this to this function in the item behind us, it'll need to check if it actually needs to stop, because it might not need to. maybe there's still more distance between the actual interval, so it won't do it if that happens. On the other hand, what we'll want is we'll say timeline movement here, so get that. We want to tell it to stop, because this is a specific scenario where if everything needs to stop, well, we need to actually stop our timeline, otherwise we'll keep moving. Next, we need to continue this to finish it, we need another timeline. So we're going to add a second one here, timeline, and this one is going to be for TL underscore, it's spawn next. And this is what we're going to use to check whether we need to spawn a new item or not. Or at least the timer we need to spawn a new item or not. This one we want to leave at 1 second, and we don't need to touch it. It's pretty much really just a delay, but we want to have it controlled because we want to pause it and stop it if that is ever needed. So we want to get a reference to our spawn next, and if spawn next is true, then we want to call our stop as well. Same as here, but we need to make sure that it exists, because once this is over, we'll destroy it because we don't need it. So let me just actually move that a bit to the side. Then we need another function very similar to this one, but for restarting. So custom event CE underscore restart movement. And for restart movement, we use a sequence directly as well. And we call our TL movement, and we can actually copy both of these, and we'll say start, sorry, not start, but play, because we don't want to play from start, we want to resume. So attach that here. If this is true, copy paste that and attach it to the spawn next. And with our sequence here, this time we'll call TL started. So this will just call the one behind it to restart if it needs to. Or if it's already going, it won't stop. Now that's an error because of this, because we haven't attached a set actor transform. So the last thing, or the last custom event we need is going to be called CE underscore end of conveyor. So this is what we're actually going to call here. So CE end of conveyor. And for CE end of conveyor, we want to call force stop, because we don't need to do an extra check, we know we're at the end. And here we'll call our has reached end, set it to true. This is what's going to tell it pretty much inside of here as well, if it needs to stop, some extra conditions. And for the next functions, actually, we can't do anything because we're missing our other functions from the actual conveyor belt, let's say. So before going forwards with, or before going back into our conveyor belts, what we'll do is we will make our little functions here, because we need some to go back and forth as well. So after condition to stop, we want a function called bind events. So bind event is pretty simple. What we'll be doing is telling these events here that they need to be called. So for TL stops, we want to call it here, so we want to do bind. We will then say create event, and the event we want to use actually is we want to call CE stop movement. And we can then call the same thing here for started, so bind. You can copy paste the create events, it will just look a bit strange until you attach it. And we want to call start or restart movement. Now for the actual target here, we don't want to target ourselves or we'll have an infinite loop in our hands. We want to call a different target from the actual blueprint, and we'll call it binding. Now I'm going to add something here. Usually I don't do this because it's kind of a waste of time. I'm going to add a description because this tends to mess a bit with people's head, especially did mess with my head when I was doing this, because I would mix up what I'm actually binding, if it's the one in front, if it's the one behind, or the current one. So I'm going to make a description to help with that. So at param binding, and what this does, it makes a reference to our actual input here, and it will tell us once we hover it this specific message, and that message will be is the item, sorry, not is, it's the item located in front. So we're precise. I'm just making sure that you know which one we're talking about every time we want to attach it. So we can't compile, so I'm just going to detach this so I can show you how it works. So if we call our bind event here, if we hover over binding, like if we sit here, there's no description. But if we hover over binding, we get an extra piece of information that says the item located in front. So that's the one we're looking for. So in our scenario, we would be attaching this one here. So we can compile and save. And now let's make the other functions. So we have two more very simple called is stopped, and another one called is last item. Now is last item we can't do yet because we need a thing from the conveyor ref, or which we don't have yet. So is stopped is pretty simple. We'll get TL movement, is playing, and we'll say is not, so not boolean here, and that's our return value. So connect it here, compile and save. And we can actually turn this into a pure cast. Is last item will have the same, actually we'll just add our return value here. It's going to be a return value, and it's a pure. There we go. So for now we'll leave this empty, we'll come back to it in a bit. Next up we have another function we'll call setup timeline. Setup timeline takes in one reference, and it's going to be a reference to our conveyor belt. So let's get that. We'll call it new conveyor actually, because what it is if we change from one conveyor to another, we inform it with this. So let's get conveyor. Sorry, very bad writing. Conveyor, a builds conveyor. Compile, and we can actually fill this one out to be fair. So let's fill that out. So the first thing we want to do is set up timeline, is we want to tell it that we are no longer at the end because we're trying to start again. We want a sequence. Sorry, not true, we want it false. If new conveyor, so search for get new conveyor here. If it's valid, so we can convert the validated get. If it is valid, we want to set conveyor ref to the new conveyor that we made. Next, what we want to do is we want to get our movement here and say set playback position. Now, the reason we're only doing it for this one, because we do have a second timeline for the spawn next, is the reason we're only doing it for one is because spawn next never, or at least should never be called twice. Because if it changes from one conveyor to the next, it should never spawn a new item again, because it no longer is on the original conveyor where it was getting released from, at least. So that's the reason we don't reset it and why we destroy it immediately after it's done. So next, what we need to do is for our TL movement, we need to tell it how long the actual spline is and how long we need to make the timeline. So we're going to say set play rate, and let's say there. Actually, one thing we also need to is make sure we remove the fire update here. We then want to do our play rate, and I'm going to add a reroute here because we're going to collapse this because it's a bit complicated. So let's do that. Collapse nodes, and we'll call it calculate play rate. We can double click on it to open it up, or actually control click to open it on another page. So for this, what we need to do is we will get our conveyor ref, and from the conveyor ref we want to get spline. So we'll get length, I think it is. Yeah, get spline length will give us the actual target of the spline. And what we want to do is we want to round this value, and we want to divide it by the conveyor speed. So I don't think we've set that up, but just for this one we'll go and set that up real quickly. So open up the build, the conveyor build. Now we can actually close all this, we won't be needing it. And we're going to add a new variable, at least now. We're going to call it speed, or let's call it conveyor speed. So if I'm just going to put it with the default value I have. So it's a type float. We compile and it's 100. That's how fast it's going to go, let's say. So with that, we can call from our conveyor ref get speed. And we want to divide our rounded value by the actual speed itself. We then need to divide this by we don't need to divide this by 100, but divide 100. Divide 10 by this. Let's move that up here. And finally, we want to snap to grid, and the grid we want to snap to is 0.01. Let's just go here, output pin, and that'll do for our calculate. Compile and save. And to finish things off, once this happens, we just want to say restart movement. Now restart movement calls obviously anyone behind it as well. So it will inform it once it's changed that if any other one was stopped behind it, once we let's say we attach a new conveyor to it, then it will know to restart the ones behind it as well. So with that, we've finished our setup. Now we just need a few more functions, but I don't think we can actually finish these until we've done in the conveyor. So now we're gonna have to swap over to the conveyor before we do the last two functions here. So inside the conveyor, we want to get rid of these, we don't need them. We're going to be just working on creating some new functions. We can actually put attach point in placement. And actually before I forget, because I noticed some issues when I was testing myself, in the, if I remember well, the update, I think. Yeah, in the update, we'll look for the spline shape. We actually need to make a very minor change here. So for the first one we have here in our first sequence, where we're looking at our first point, we actually need to change this from 500 to 300. And we want to change our B to get last spline points -1. So there we go. Let's combine these. The reason this is, and I'm not exactly sure why, it makes sense why, is once I started trying to move items along the line or along the spline, sometimes if the distance would exceed 700 or so, it would end up having a small flip at the beginning and the item would turn 180 degrees and restart again. And this is the solution I found to that problem. We also need to do the same trick here. So the one right below it, we put it to 300 as well. And with that, we're done inside of here. We don't need to touch this anymore. That should fix the issue. Let's make our new functions. So for the new functions, we can start off by first making a new category for them. We'll call it items. We'll start with get transform by alpha. Sorry, not like that. That's very poorly written. By alpha. There we go. So what this will do is it will take in the alpha that we're going to give it with our actual alpha here, bottom, and it's going to inform it what location it should have. So it takes an input of alpha, obviously, because it's a private variable. We take in a float and we return a transform. So just simply call it transform, a transform node, and we can make it pure as well. Now for the actual value here, we need to do a bit more than just simply get distance along spline, because our spline can be in any direction. So it needs to know that. So what we want is we want to get spline here. We're going to call get spline length, and we're going to need to use this twice. First, what we need is we want start direction, and we also want end direction. And with these, we can actually inform it which direction we're going. So what we want is we want a select node here. And if the start direction is an output, we want to set it to spline length. Let's just move these, and if it's non-specified 0, if it's an input 0 as well. Next, what we need is the same thing here, but instead of start, we'll have end, and we'll need a copy of this as well. And if it's output again, we'll be telling it to be spline length. And these two will both go into our actual, into a lerp, which is what the alpha will use. So how this works is pretty much if start direction is output, then that means end is automatically input because they're inverted. So the same is true in the other way, and that's how we determine the direction. So we're going to put both of these into a lerp. Start will always be A, end will always be B. And for alpha, we will get our alpha variable or alpha parameter. And with that, we need one last reference to our spline, which we'll then call get transform at distance along spline. And we put in our distance here, make sure it's world, and attach that to our transform. So we can then say compile and save. That's our first function. So let's put it in a new folder called items, and let's move on to the next one. So we want a function called get length by alpha. So get length by alpha. And for get length by alpha, we want a pure node again. This time it's going to be a float again, so alpha once again. And the return is going to be also a float called distance. And to get the result we want, we need to once again call our spline here, and we need to get its length. To get spline length, and this time it's going to go into a map ranged clamped. The value is alpha, it's going to go 0 to 1, and output range is B, because this time we're specifically looking for the distance, and the distance always goes up. There is no negative even if it goes in the opposite direction, its distance is still positive. So make sure it's pure, and we can move to a next function. Next one is called setup linked builds. Now setup linked builds might not be doable just yet because we need to do our buildings for that. So yeah, so we'll ignore this one for now, and we'll move on to the next one, which requires we actually make our variables. So right now this can actually all go, we didn't sort them earlier, but I like to put them in a folder called chain. Not chain, chain. There we go. And the same for all of these because they connect the different parts of the spline mesh. This will be in items, we'll do that as well. Items. And for the speed, what we want is we leave it as is, but we also need some other variables. We need one called last item in queue, which will be of type A item. Save that. And another one which will be of type items on conveyor. And this one is of type items as well, but an array. So with those three items, we can now move to our next one, and that is can spawn next item. So let's do that. Can spawn next item. This is what will be used by the actual buildings to tell if it can actually spawn a new item for this specific conveyor belt. So for that, we simply need to call our last item and see if it can actually spawn something, if it's close enough or too far. So for that, we want to call get distance. Okay, so we don't have that function actually yet because we need some other ones as well. So once again, we need to kind of go back and forth here. So for that, actually, maybe what we'll do is we'll just go back into our item and make the last functions first, even if they don't have the information. So we want a function called get distance along spline, and it will simply return a float. So return value type float. It's a pure item as well, a pure function. And we'll need one more, which I think we already made. Yeah, so that was the last function. We just needed this one. So here what we'll call, back in our build conveyor, we want to call get distance along spline. And we want to call here item interval. So What we'll do with this is actually check whether we can spawn an item based on its distance and the item interval we've given it. So we want a return node. If it failed, that means that there's no actual last item, and it's the first item we want to spawn. And in that case, we simply tell it, well, return value is true. We can spawn a new item. Actually, can this be? Yeah, this is pure as well. So with this, what we want to do is we're going to say get distance along, say minus. We're going to subtract the item interval. Now the reason we're doing this is we could just say this. If that is superior to that, then that means we can spawn it because we have enough space. But what I noticed is that sometimes you'll have an offset of like 1 unit, and that sometimes leads to an issue. So what we do is we say nearly equal here, and we'll give it an error tolerance of 1. And so if either of these are true, then that means we can spawn something. So we'll add a return value on valid and plug this in right there. Compile and save. So spawn next is done. Setup linked build should not be a copy of this. Let me just get rid of those. Compile that. So we'll leave this one for now. Next, we need items added to conveyor. So let's get that items added to conveyor. So I'm actually going to put this in items, but I'm going to add a subcategory called manage. And there are going to be 4 functions if I'm correct. And what these do is they will be able to tell us when an item is added, when an item is removed, when it moves to another conveyor, and when it's picked up. So when it's consumed, sorry, by like, let's say a constructor later on. So for inputs, we want an item. So this is new item of type A item. Let's go and not a class type. We want it specifically to be an object reference. But this time for this one specifically, we also need something called update last, which is going to be a boolean. So let's compile and save. The first thing we want to do is we want to get our items on list, and we're going to say add, and we're going to add our new item. Just going to line these up and plug it in there. Next, what we'll do is a sequence, and for the sequence, very simply, we're going to have 2 branches. One for, sorry, we actually don't need a sequence here. Put a branch here, and we're looking for update last item. If update last item is true, we need to call last item here, check if it's valid, because if it isn't valid, we can ignore some parts. Or at least, sorry, if it's not valid, we need to add it. So what we do here, if it's valid, we'll say unbind all events started. On the other hand, if it's false, what we want to do is we're going to call our last item in queue and tell it to set it here. Well, at least set it to new item, sorry. There we go. Next up is we need to update the new item here and tell it which item is in front of it. So for that, we'll say item in front set. And the item in front is obviously going to be the last item in queue. So we can get a reference to that because that's the only one that's in front of it, and it's the one that's going to be replaced very soon. Then what we need to do is with our same item here, we're going to say bind events. As we mentioned prior, if we hover binding, it's the item in front we're looking for, so it's the last item in queue once again. Let's just move that there. Let's align these 2, place it here. There we go. And we also need to update our last item in queue, which we're going to do separately here. We're going to have a function for that, which we'll call update last item in queue. This one we'll leave in the actual just normal items. So now we'll leave it empty, and we want to call that here. So we just need to actually add an input of type new item. So this is the new value that it will have, and it is of type a underscore item. Sorry, a underscore item. There we go. And so the new value will in either case be set to this. But in the event that we don't have a valid answer here, we can't do any of that except for this. So we just ignore everything in the middle. I'll save. And with that, we finished our add new item. Now, if we don't want to update the last, then that means that we're talking about something on a different conveyor, and in that case, we don't need to touch it. So in that case, because this will be called once we spawn a new item from our building, but it will also be called if we go from one conveyor to the next. And when we go from one conveyor to the next, we never want to actually change our last item in queue. So we don't need to do any of this because it'll be done separately. Next function we need is the item pickup. So this is going to be quite complicated because we need to update all the information from all the different variables, let's say. But we need a few more functions to do that, so we'll actually leave this function for now. We'll do it once the rest are done. Okay, let's close that. So next function is we'll get item moved to next conveyor. So we'll duplicate our items added, and we'll replace this name by moved to next conveyor. And we don't need our update last, we can remove that. And let's just get rid of all of this for now. First thing we need is our items on conveyor. And we're going to find the actual new item. Or in this case, actually, we'll rename it to item moved. So I'll just get rid of that. So item moved, get a reference to it. And the reason we need this reference is because we're going to delete it. But we also need to keep the information of which one was removed. Actually, we don't need that. I don't seem to use that in this one anymore. So let's remove that. And what we want to do is simply, from our items, sorry, we want to remove item, and we'll remove item moved. The reason we do this is because we're calling this from our, what's it called? Our current conveyor, so where it currently sits. And we're going to make a function here called get next build, and that's going to be used to inform which new one is there. So what we'll do is we will make that function very quick. We're going to say cast to a builds, and we're looking for conveyor. And actually, I don't know, this won't work. So we'll make a new function very quickly. We're looking for get next build. We'll also need another one called get previous. So let's just get those out of the way. Actually, sorry. Don't duplicate it. What we'll do is we'll first add the return values. So first we want to return value, which is going to be if we actually have a next build. Then we want the out build. So that's going to be of type A build, and make sure it's the base one, the base class. Next we want another one called attach point, and this is just if we need a reference to the attach point instead of the build directly. So a attach point, and we can close that. Now we can duplicate it actually. So put it back in, put it in items, duplicate it, and instead of next, this is previous build. Compile and save. We can close these two for now. Inside of items moved to next conveyor, we want to call get next build. And for the out build, because this is going to be used for any build, because if we're hitting a actual building like a constructor, we also need to know what to do. So for now, we're going to say a build, a builds, and we're looking for the conveyor. Yeah. So what we need here is we will call from our items conveyor and we'll say items added to conveyor. So it knows that it's actually referring to the new place, so it's adding it to the new one, but we need to make sure that update is not selected here. So item moved is what we need because that's the one that's leaving, and that's the new item. So we also need to call here when we do that, sorry, reroute here. We also need to call the function setup timeline because we need it to know that it's moved. And so to set up timeline, we also need the new conveyor here. So plug that in. That does it for items moved to next conveyor. We can also make a function for item consumed, but for now we don't use it. So we'll make it, but for now it's not and doesn't serve any purpose. So let's actually duplicate our items moved to next conveyor, and we'll call it item consumed. Very simple. It's going to be left empty for now, as I mentioned, because we don't have anything that actually consumes it, and we won't be making that right now anyway. So consumed, and there we go. So next function is we want to call item picked up. So the same thing here, like item consumed, item picked up. Now this one is a bit more complicated, and we do need to actually do it. So for item picked up is kind of the thing where everything tends to go wrong, because you start picking up an item and you need to inform which items have moved where and which ones need to refer their events to one another. So for that, we'll start off with setting not setting. First we want to promote to local variable, which we'll call L item picked up. Oh, apparently it's not writing what I need. Okay. L underscore item picked up. There we go. We'll start with a sequence. Let's put it here. And the first thing we'll do is we want to check if our item we picked up is the same as our last item, because that will change what we have to do quite significantly. So let's put a branch here, first sequence. There it goes. Start. So with that, if it is equal, either way, no matter the scenario, we're going to tell our items on conveyor to remove the item we picked up. Because either way, it's going into the player's pocket, whether it arrives there or not, it is removed from the conveyor. What we need to check is if the conveyor is empty now. So it's not empty, we'll use. If it is not empty, we're going to be telling the last item to become the last index now. So we'll get our items on conveyor. We will get a copy, and the copy we're getting is the last index. So the last index gets plugged in here, and we use it to set the last item in queue. On the other hand is next, if the last item in queue, or at least if our index is empty, then we set this to null. Now we can add a reroute here because we have the last little thing to add, and that is we'll get our item picked up here, so our local variable, and we're going to tell it that we'll tell it to call spawn next. Now the reason we do this is it means that if the player picked up an item that has just spawned and hasn't had the chance to spawn another one, because it's the only one on the conveyor, we're going to tell it, well, it doesn't matter, spawn the next one in, because the distance between them is always enough in this scenario. So we'll tell it to spawn next, and we will then destroy this actor, because it should no longer be visible. Let's go here, align those. If our last and item is not the same, what we need to do is we need to get our item picked up, and we need to find it inside of our items conveyor. The reason we do this is because we need a reference to the index so that we can inform the actual other items that they need to be readjusted relative to this one. So we're going to promote this to a variable. We'll call L index removed and put that on false. Give it a bit more space right here. And what we'll do is we'll check if this is equal to 0. Now, if this is equal to 0, that means we just removed the first item in line. So not the last, but the first. So the one at the front. So in that case, we need to get our item picked up. We need to get items in front and create a variable called item in front. Now, the reason we have this, because you're probably wondering, it's the first item, right? Why would it have this? Well, assuming we have two conveyors connected, then even though on this conveyor it's the first one, it might have one in front of it. So we need to be aware of that. So with that awareness, we then take the item on conveyor, we get number 1, because it's the value after our actual 0 here, because we know it's number 0. And what we'll do is, if it's valid, so it's valid, then we will tell it to set item. So actually we don't have a variable for that. We will reroute here. And what we want is, right now we're going to say set item behind. So item behind. So now what we have is we have the item behind, we have the item in front, and we have the item picked up. So with that information, we can start moving the information and telling it which ones we need to update and which ones they need to be updated to. Next is if we're just any random, no, actually first we'll be checking for the last one. So with another branch here, we'll copy this. We'll keep the equal as well. Actually, we don't need to do that. We can get our index removed here. And what we're looking for is with our item on index, we will get last index. And if these two are equal, we're going to tell it, well, it's the last index. So because it's the last index, we need to check between whether the one behind it does actually exist. So once again, the scenario is if we have two conveyors, we need to know. So the first thing we'll do is we will copy this. In most cases, we will be reusing it here. And what we're looking for here is our actual get previous build, because we don't have anything set up, and I think it's better without it, referring to an item behind, because we don't need that very often. So what we'll simply do is we will cast here to our conveyor. And if we fail to cast, that means there's nothing behind. So that means we're in the scenario where we have, let's say, a building behind that just spawns the items. Then in that case, there's no items behind it, so we don't need to worry about that. But if we do have a conveyor, we need to get items on the conveyor. We need to get our first item. So we're going to get a copy of 0. And we're going to check is valid. And if it is valid, then that means that the item behind us does indeed exist. If it does not, once again, not valid, we set the item to null. If it does exist though, if it does exist, we want to set it to item behind. So let's just reroute that here. And for the final one, which is the last branch here, is if none of this happens and none of that happens, then that means that we're an item in between. So we're working inside of the conveyor, we don't need to worry as much. We call our item in front again, put it here. And this time, very simply, we get our index removed. We get a reference to our items on conveyor. We say get, if I remember well, yes, get, and we want to add 1 to the value that we are trying to remove. Go attach it here, and we will call is valid once again. And if it is valid, then that means we have a item behind. If not, we don't. So item behind here, apply, put it here. And if it is not valid, we'll just leave it empty. So let's align all this. There we go. One last thing, which is the sequence here that we didn't do, is this is going to be the actual part where we take our variables we've set up as we went along, like the behind, the in front. We're going to take those and tell them what to do with it. So let's move this a bit forwards here. Go. And with that, the first thing we need is we're going to start off by removing our item. So remove, and the item we will remove is the item picked up. So attach it here, and we remove it. So next what we want to do is we want to check if item picked up is valid. So I don't think we need to do that. I just made a mistake in my one. We don't destroy it here. We'll be destroying it here. So we destroy the item we picked up, because now that we've removed it, we've done everything we need with it, we can destroy it. We want to check if our item behind exists. Now if item behind exists, so to do that, we check if it's valid. If it is valid, we want to restart its movement. If it's not valid, we do nothing. We don't want to do anything if the item behind is not valid. And if the item in front is valid, so convert to validated as well, we only want to call out of our restart movement here. We want to tell it to set in front. Sorry, no, I got that wrong. We want to call from item in front we want here. I want another reference because it's easier, and item behind we want here. We need to tell the item behind that the new item in front for it, and make sure you choose the actual variable here, is the item in front we've determined. So we call that here. And with that, with our new item in front here, sorry, not a reroute, not like that. We want another reference to behind, and we want to tell the behind to bind its events. And once again, as we mentioned in our description, we're binding to the item in front. So we get a reference to our item in front and call it here. So we can compile that, and this will deal with our item picked up, which is by far the most complicated scenario because it's by far the most annoying one where the player can do anything. Because the machines will always work one way, but the player can pick up anything he wants. So we need to be very sure about how this works. So next, to make all that work, we don't touch the consumed. We need to work on the get next build and get previous builds. We actually also need to do the last item. Actually, we'll do that first. So open up last, or update last item in queue. And the new value obviously is going to first set last item in queue. But after that, we need to inform the other conveyors, because this is actually a universal variable across all connected conveyors, that the last item is this. So to do that, we get next build and we perform a cast. We cast to conveyor, and if that is true, if it is the conveyor, so if our next build is a conveyor, we want to check if get last item in queue is different from our current get item in queue. Our current get last item in queue. And if it is different, then we're simply going to call this actual function recursively. Because what it will do is it will tell each one to only change if it is different. So here we'll call update last item in queue, and the new value is our last item in queue. And so because of how this works, it will inform its next one and its previous one to do the same trick. So we can actually copy this here for the second sequence, but instead of next, we want to get previous build. Attach it here and plug the out build. And this will do the same thing, but in the previous case. This is in front, this is behind. And these will call each other, but they'll only call each other if they need changing. So once we've checked that, we've finished our update. Now we actually need to make sure that the setup and our other variables are all done. So next we want to get our next build, and we'll do this one first, and we'll copy most of it to the previous. Get next build, we want to start off with a branch. We need to check whether our end direction is actually our end. So double equal, not that one, the double equal enumerator, and plug it in to output. So if it's an output, we can connect that here. And what we want is we want to get this end and convert it to validated, because we need to know that it exists, because sometimes that can have an issue, that can be an issue. And we want to actually, I don't think we need this because in either way we make it anyway. So what we want is we want to get connected build, and we'll add a return value here, plug our connected build here, and our attach point is this end AP. On the other hand, if the opposite is true, then we can copy this and, sorry, I actually made a mistake here. Yeah, no, sorry, I need to double check. Yeah, sorry. We need to check if the connected build is valid, because if the connected build isn't valid, then we can't really do this. So if it's true, we can do that, no problem. If it's false, then we need to return false here like this. And we'll copy this because the same thing applies here, but the difference is instead of end, it's going to be start. So let's just realign all this. Replace this end by this start. The same thing here, this start and this start. Just making sure. Yep, so that will do the begin. So we can delete this. Now we can copy all of this and we're going to go to the previous, and because the actual outputs are the same, it doesn't matter. So plug this in, and unlike before, we'll leave this a bit different. It will be a bit different. Instead of end, we're going to look for this, but what we'll do is we'll simply invert these two. Or actually what we can do, we'll swap this to input. If it's an input, it will go through the end. Pretty much the opposite of what we did for these starts. So that should do it for all of these. We only have one function that we can't do, which is set up linked builds. And the reason we can't do that is because we don't have our builds or our buildings set up yet. So let's actually go back to our items now and finish what we started here. So for the items, what we need to do is we need to get distance along spline. So if we get distance along spline, if I'm correctly, let's get that open. All we need is we want a reference to our conveyor. We want to get length by alpha, and we'll call alpha here. So get alpha, and this will be plugged into our distance. Now I'm just double checking we did do that. Okay, no problem there. Let's compile and save. That does it for our first function. Now we can also do the get, we can also now finally do the condition to stop. So actually first is last item can be done first. We want conveyor ref, we want to get last item, and if it's double equal to self, so get self here, then that means it's the last item, otherwise it is not. Very simple. Close this, is stop is fine as well, bind events is done, interact with actor we need to set up in a bit, and setup timeline is done as well. Get distance is done. What we need to do is condition to stop here, which is the most crucial one, let's say. So remember, when we call this in the scenario normally, we either way have to check this. Actually, sorry, we can add here stop movement to the actual condition. So either way, actually, we don't need to call stop movement. We can call stop and force stop. Force stop here. So when we call this, we automatically have item in front valid. So that's why we can do this as a pure pretty easily. So first things first, we need an AND node here, because we want to check if item in front here is stopped. Because even if we're very close to the item relative to our interval, if it's not stopped, then that means it's moving. So we don't need to worry about stopping. On the other hand, we need to have a select here. And for the select, we're going to have a Boolean. Now the Boolean is very simple. we want to get item in front, we want to get conveyor ref, and we want to check whether this conveyor ref is the same, because we need to know if they're on the same line, because the calculation isn't the same in that scenario. So plug it in here. If they're on the same, what we need to simply check is we will get item in front, we will call get distance along spline, we'll then call get distance along spline here, and what this will do is it will say minus, and simply if this happens we check if it is superior, or sorry, we check if it's inferior to our interval, and if it is inferior then we need to stop, so this goes into true. Now for the false it's a bit more than just this. We need to get conveyor ref and we need to get spline length, and the reason we need the spline length is because we need to know how long it is relative to where the one in front is distance wise. So we need to subtract get distance along spline, and we then need to get in front distance as well, so copy that directly, and we want to add these two together, and it's this addition that we compare to interval this time. So that gets plugged in there and into the false. We can then compile, save, and that does it for our condition. And I think with that we're done. No, we need to do the interact actor. Then we have finished with our actual item. So currently it will move along the spline, but the problem is we don't spawn it yet, so we need to set that up. First thing we need to check with interact is get spline, get conveyor ref, and we need to check if it is valid, because if it's valid we have something we need to do, which is item picked up. The item is obviously self, and here if it's not valid we can return false. So what we also need is get player character here, because we need a reference to tell it that it picked up the item. So cast to FPS satisfactory, drag that here, and what we'll call is our pickup item. And for the pickup it is self. And this is the only scenario where we get true, otherwise we put it as false as well. That does it for the interact with actor as well, and that should do it for our item. We haven't even finished our event graph yet, so let's actually, before we go and close this, we need to finish the event graph. Because on event begin play it's not just supposed to put a sequence. That is not very useful. So we're going to get a conveyor ref here and call item added to conveyor. Now because it's on begin play it's only called once, so this is why we can tell it to update last here. Item is self, and we can align that here. And on the actual second node we want to call setup timeline. And what setup timeline will do is it will start our timeline here and give it the length it needs. On the other hand, we need to do the same thing for our other timeline here. And to do that, we need to say for our spawn next, we need to say set play rate. And the reason we're doing this here instead of there is because we only call it on begin play. So let me just get this here, line it. And for this one, we want to get conveyor ref, we want to get speed, and we want to get item interval, and very simply divide this by that, and that'll give us the actual speed we need. There we go, new rate. And here what I found was pretty useful is adding a tick until a delay until next tick, because it seemed to smooth it out, I guess you could say. So we call play on start here. Let's just move everything a bit down so we have a bit more space. There we go. So this will be called it starts, and what we simply wait for is once it ends in 1 second or 1 times the actual speed, we call spawn next. And what we do then is we also delete our actual spawn next. So destroy this component because we don't need it anymore. So destroy that. And we can move on to our actual proper movement here. We have our condition to stop, no problem. We just need to now set up our condition to if we need to stop at the end or if we need to, well, set our final transform, because currently it won't move. I'm actually stupid and earlier said it would. It will not. So get conveyor ref here, and we're going to get transform by alpha. And in this case, we're going to leave it at 1, because this is going to be used to check whether we reach the end. So we're going to double equal here with an error tolerance of 1. And we're going to copy this because we need the exact same thing here. But instead of alpha 1, we want the current alpha, so where it's moving. Apply this here, put the boolean on condition, and our new transform right there. And that will do it for the movement. So let's compile and save that. And I'll just double check I got everything this time. Okay, so still not everything, because we still need to finish our actual end of conveyor. So for the end of conveyor, now that we've done our conveyor ref finally, if we reach the end, this is automatically true, so we don't need to worry about that. We'll call get next build. Now why we do this here is so that we know that if the item is at the end, we can start calling this. So we'll check if there is another conveyor after, out of the build. And if there is, we're going to reroute this below, and we're going to call from our conveyor ref here, the current one, we're going to say item moved to next conveyor. And the item moved is obviously self once again. Now the reason we do it this way is because, as I mentioned, it needs to start in the current conveyor before it starts doing something else. So we don't need to call actually anything else here. We just need to check whether we are on a new conveyor. On the other hand, if we aren't, we need to tell it what we are hitting. So normally empty would mean we just stop, we don't do anything. But now we're going to make another actor which will be placed here. So we're going to have to go and do that now. So let's just compile and save. We'll leave this open because we still need to come a little bit back for this and for this last bit here. The first thing we want is based on our builds, so our basic builds, we're going to create a new child blueprint. And this child blueprint is going to be called A buildings. So this is specifically for structures like constructors, smelters, and stuff like that from Satisfactory. So to get them to work, what we'll need is a few things. So most of the logic is going to be done inside of the parent actually building, and we're going to have then a smaller one for the container after, but we don't actually need it that much. We only need to make most of the work in here. So for that work, we need a few functions and we need a few input outputs, let's say. So actually, we also want to add a interface, because if we interact with these later, we want to have a widget appear so that we can activate an item or manually drop it in with our inventory or stuff like that. So we're setting that up, but we're not going to do it for now. So once you've set our BPI in class settings, we can move on to our variables. So for the variables, we want something called outputs, which will be of type A attach point, and it's going to be an actual map, and the value will be float, and the float is actually going to be just how fast we can output a new item. We do use it like this, but I don't seem to use the actual float, but for now I'm going to stick to this. If at a later date we need to change it, we will. So back in buildings, we can now start with our inputs, which will be the same thing. It will start with a attach point, but this is where we actually use the inventory that we made. And the reason we use the inventory is to actually inform it what item is currently sitting in that attach point for the input, because if it's at its max stack, we don't want to keep putting more into there because it cannot accept more. So we have inputs and outputs. Let's put them in their own category because the functions will have that. So we're going to just do it for the variables as well. Next, we have item spawn interval, which I mentioned earlier is going to be global across all of these items. And it's going to be a single float, very simple. And its default value will be 100. Put that there. So compile. That does it for our variables. Very few. We don't need that many for this. But obviously, if you have more complex children, you might start to need to add more stuff. But for the base class, this is all we need. For the functions, let's get into those. We start off with a conveyor attached output. We then want to have that be of type, let me just check what we have. It's going to be very simple. It takes in a attached point. Sorry, not attached like that. Attached point, or we'll just call it attach point will work as well. And it'll be of type A double T, not underscore we need, sorry. Attach point. And we'll go through it straight away. We'll do them one by one. We start off by getting our connected build. And in this case, normally we should always have a conveyor because that's all we can connect really. But we need to do a cast anyway because the reference wouldn't be correct otherwise. If it fails, we just return. We don't do anything. If it's succeeded, sorry, we will get new speed here. Oh, sorry, get speed of conveyor. And we want to get item spawn interval. And we will be dividing this one by the other. And this will go into our actual outputs here. We'll say add. We'll be adding the actual attach point that we got. And the float will be the variable I'll be using for the speed. Now, as I mentioned before, I don't think we use the speed. So this could be an array. But for now, we'll leave it as is, just so I don't make any other mistakes. Then, before finishing, we need a new function, which we'll be calling start outputting. And it doesn't need any inputs or outputs. It's simply called once this happens here. And then we can add a return, even though it doesn't serve a particular purpose here. We'll move on to start outputting. Actually, we won't because we need to add some conditions first. So first we want can output item, which will return a boolean, obviously. Return value of type boolean. And then we want one more, which is output from attach point. So for start outputting, we need to leave it empty because this one is what we're going to call from another function, but we leave it open so that inside of the children we can modify it at any given time to do what we need to output what we want in that specific child. So we put all of these into an output. We can close this, we can close the conveyor attach point, and we want to work on can output item here. So sorry, can output item. Now by default what we'll do is this will be true, because in our current scenario, we're never going to place the A buildings, but because the parent class will always leave it as true by default, that way it always spawns. Next, we want to check the output from attach point, and this is the actual one where we're going to do most of the logic. So we'll start with a branch, and the branch will be very basically can output item, which we should make pure, actually, makes it a bit easier. If it doesn't work, we return the value, and that is a boolean to just inform if we succeeded in spawning an item. So if you have any bugs, you can add here different values. So for this one, if this occurs, it means that we cannot output item according to the item here, according to the buildings. Next, what we want is with our attach points. Sorry, I made a mistake. So output from attach point actually needs inputs as well. It needs the attach point, which is going to be of type A attach point. But it also needs to know which item it's outputting. So this time, not A item, but DA item, because we want the data asset, because that's what's going to be stored inside of the actual whatever it is, constructor, or if it's even a simple container, it will use a data a data asset, not an actual actor. So this is the, let's say item data. And so what we'll do with our attach point, so get attach point here, we'll look for get connected builds, and we will cast to conveyor. And if it's a conveyor, what we need to get is we have a can spawn that we made earlier. And that will check pretty much if in front of this item we have enough space to spawn the next one. So if this fails, so return value here, that means that the cast failed. That means for some reason the connected build isn't working correctly. On the other hand, if it fails here, so return, that means that the spacing between the items is wrong. So if you want, you can always add this as a note here or add a print if you need. Now, if this does work, we want to reroute here. Sorry, well, maybe not a reroute. We can just use this actually. Well, we do want to reroute. I was going to make a variable out of this, but that might not be necessary. What we want to do here, if all of this is true, we want to spawn an actor from class, and that class is going to be our item. We're going to spawn an item here. For the spawn location, we're going to get from our conveyor here, reroute again. We're going to call get alpha. We're going to get our transform by alpha so that it knows exactly where it is at 0. For the conveyor ref, we'll add another reroute here. It's going to be our reroute node that we've been pulling along here. For the data asset, it's going to be our item data. So let's just line all these up. And for the item interval, it's going to be our item spawn interval. So align all these up, and that does it for our spawn. One last thing we need to do is we need to inform it what to call once we tell it to spawn next. So here we're going to bind event again, but this time we're binding specifically the spawn event and not the other ones. And the event we want to bind it to, we're going to call create event, and it's going to be our start outputting function. So we can compile and save, and that does it for, actually no, we need to put a return here to say that we succeeded in spawning our item. So next what we need to do is the same thing for the inputs, but for the inputs we don't use them yet, but we'll set up the functions that they're ready to go when we need them. So conveyor attached input. These are called, by the way, the input and the output are going to be called once a conveyor belt is attached to them, so they automatically start spawning the items if needed, or starts moving the items in. So in this case, we need the attach point. Once again, so attach point. And this one we can leave empty. This one we don't need to touch. Next, we want to duplicate can output item, but this time we want to can input item. Sorry, we need an I there. Can input item is, unlike the other one, we can actually do most of the logic here, but it's not null. We need to actually have, it's not no inputs. We need actual inputs here because we need to know where it's coming from. So we need the attach point, and we need to know what item is trying to come in. So input item. Input item is of DA items type. The first thing we want to do is we want to check whether our input can find the actual attach point, because otherwise there's an issue and we don't have the existing attach point. So we'll have a branch here and attach that there, and if that happens, well, it's false. We can't spawn anything if we don't have anywhere to spawn from. If we do find it, then we can get the input point and break its data so we know what's in there. And what we need to do is we will reroute this data asset and we will get its max stack. And what we want to check very simply is first if these two are equal, because if they're not equal, it means we're trying to input a different type of item inside something that already has one. So we'll say false there. And there we go. And if it's true, so if it is the same item, what we determine allows us in is if quantity is inferior to the max stack, because items always come in one by one. That means they always have as long as we're inferior, we can always add one more. So we can close this, it's already done. And the last one we need is input from attach point, which is going to, we can duplicate this, but we're just going to convert it back to a normal cast. And we don't need, no, we do need, sorry, our boolean again. We'll just get rid of all this. We'll rename it to input from attach point. And what we check is, in this case, we'll just say destroy. So in this case, we do need the actual A item because we need to know which one we destroy. So destroy actor. There we go. And we return true in this case. So as I mentioned, the inputs, we're not really using them, but we're still setting them up so that if we have to do them at a later date, they're ready. One last thing to do is modify item quantity. So item quantity. So this is just something very simple, just that we don't have to retype every time we need to modify something. We can just modify it with this. So the input we need is of type inventory. So search for inventory. And we want to make it a pass-by reference. So this is item slot, we'll call it. And we want to add a modifier value, and that's going to be an integer. It doesn't need to be passed by, we just want it to be an int. And what we'll simply do in here is we're going to break this structure. We just need the quantity, and we will say plus the modifier here. And what we'll do is we will call the function set members in st. And the member we want to set is the quantity. So we plug that in here, and then we can add a return node. And in my case, just to be sure, we can add the output as well, so that we know if we need to, we can check it just to be sure that it's correct. So with that, we've finished our parent. Now it's time to actually create the new child, or in our case, the container. So let's do that. Create child blueprint, a buildings, make sure you call it buildings, and we'll say container. We can then open this up, and before going any further, we actually need to import an asset for it. So in Satisfactory, in assets, let's call it a new folder called buildings. And for the buildings, I'm going to go and import my item. Let's import it in. There we go. Import all. It's not very pretty, but it does the trick for what we need. And we're going to set that up. So inside a container, first thing we want is we want to add a static mesh, because it's an actual item that looks like something. And it's going to be our container. Sorry, I called it constructor, but that's not what we're using it for. So there we go. So we'll have to rename that, but it doesn't really matter. So with our new item here, we can actually go and place it in the world. So let's do, actually, yeah, we'll put it in here. So right there. So let's move it here. Now the next thing we need to do is we need to, actually, now that I think about it, I think I forgot something in the buildings parents. Yeah, I thought so. Yeah, one thing we need to do that I just remembered in our buildings, so this one, in the event graph, after our begin play, we want to get all child actors, and we want to look for each loop. And what we want to do here is inform all attach points. So we want to cast two attach points here. And we need to tell the attach points that their parents are, or the parent build is self. So set parent build here. And we want to set it to self, so that it knows which, if we attach something, because the parent build is what determines how to link the stuff up, we need to tell it here, once it spawns, what its parent build is. So the whole reason for that is because now we're going to add a child actor, which we're going to be calling, let me just pull it up here. We're going to be calling it CA for child actor. Sorry, let's put it in capital. CA child actor output, which is going to be of type attach point. and it should appear in the middle there. And we're going to have to move it a bit. So let me just double check where it goes. We want it to be at 150. We want it to be at 0 on the Y and 50 on the actual Z. And with that, what we will call it is we will tell it to change its actual variables. So open the child actor template in setup. We want the arrow to be visible, but we want it to be an actual, so in this case it's an output, so that'll be red. For the offset, we also want to set it to 0 and 40. So that way it kind of wraps around this. We can actually make this maybe a bit longer. Let's put it at 50 as well. That way it's a bit bigger, so we won't miss it. We can also, now we want to duplicate this, and this time it is going to be called input. And for input, same thing pretty much, except it's going to be obviously input instead of output. So this will be minus 150. And we want to make it rotated by 180 degrees. There we go, that's what it was. So once it's rotated, it actually looks now, it comes in here and goes out here. So if we look at it in this map, yeah. So this is how it works. It will go inside of here and come out there, and it will store items in between if it needs to. So what we need to then do obviously is check whether items can come in and etc. So all we need in our case is output, because we're only doing the actual output. So what we need is one thing, is storage. So we need a variable for that, which will be storage, very simply. And the variable type will be an integer, because later we'll be doing it in slots of an inventory of sorts. So we then want to call our inventory structure. And by default, we'll add one value, and we'll say, let's call it iron ore, and we'll make it have 10, let's say. So we can test it once it starts spawning. Then we need to go and override our start outputting, but we also need to override our can output item. And the can output item is very simple. We're going to have an and here, and the reason we do this is just in the event that we ever change the parent instead of just ignoring it, because it's always true currently. So we just want to check if this is not empty, that means we can spawn an item, because we already have a check when we actually spawn an item in our buildings. Can output item here, no, sorry, in output from attach point, we already check if we can output on this specific conveyor. So we don't need to worry about in here whether we can do that. So we just want to check locally whether the items exist. So we can close that. For start outputting, we need to do a bit more than that, because in this case we have one output, but we're also going to design it so that if we have a second output, it can manage that as well. So we want to get outputs. We will get our keys here, and with our keys we're going to do a for each loop, and we need to get storage here, sorry, not that, get storage, our map that we made. We want to get our keys as well, and what we'll do is we're going to get the first index, so get the first item of sorts. We're going to find it with that index, so wherever it's located it will find it. And what we want to do is from our attach point here, or more like from here, we'll call output from attach point, which will go to our keys. The attach point we're using is the one we've notified it of here. And the item data is going to be with this. We will break this and connect item data. Hide unconnected, we don't need them. Let's line this up. So with this, we will actually attempt output. And if we cannot, we don't do anything. That means no items spawn, we don't need to worry about it. If we did, on the other hand, we want to reroute this and say modify quantity. And the quantity we want to modify by is -1. What we need to do then is with this, we want to check if our quantity is inferior or equal to 0. if it is, we're going to actually destroy our storage value. So the reason is, well, how we're going to do that is we're going to get a reference to this and we're going to reroute it all the way across. So all the way here, because we need to first tell it with our storage here. We need to add, and the reason I'm doing this is because sometimes, I'm not sure, but sometimes this doesn't save properly, even though we're doing it with a pass-by reference. Sometimes it doesn't save it, or at least in my experience I had a few issues, so I just prefer to do it this way. So we just add it again, and we check with a branch whether this is empty. And if it is empty, well, we're going to get a reference to this again, and we're going to tell our storage to remove this item. Here, there we go. File and save, and with that we're done inside of building container. That's all we needed to do here. Now we just need to finish things off by going back to our item here and to our actual conveyor belt and doing the last little things we're missing. So here we want to call cast to a buildings. So make sure you choose buildings and not building. Sorry, buildings, yeah, and not builds. We want to call input item, attach point here. This one isn't used as I mentioned before, but this is how it would be used. So we'll get our attach point here, plug it into attach point, and the item is going to be self once again. So get self and plug it like that. For now it doesn't do anything, but in the future we'll need it, so we set it up anyway. Now inside of builds we need to set up our, well, set up linked builds. So let's open that up, and this one is going to be pretty complicated, but it's not that long. It should take maybe 5-6 minutes. So we'll start with the sequence, then we'll have a second sequence because it's easier to split things up like this, and we'll start off by getting other start. Now with other start we want to check if it's valid, because in this case these, or at least this one and this one, they're always valid, but the others are not always. So we want to get parent build, and with parent build we will perform a cast to buildings. So with this we check pretty much once we've set them up, because we're going to be calling this once the function is attached, we've confirmed our build. We will check whether they exist, so we need our direction here, and we're going to do a switch, and if they exist and we've done our switch, we can tell it with that which direction we want it to move and how it will move accordingly. So we'll reroute this, sorry, not that, reroute, and we will tell it to conveyor attached, in this case input, if it's here, and we will get other start, because that's one we're working with. And if this is not the case, if it's an output, we will say conveyor, but we need a reference to this, conveyor attached output. Go and get other start again. Now let me just double check. We then also do the same thing, but this time with end. So let's just do this here. We'll right click and replace it with other end. And we'll keep it the same, but we just need to swap this to end as well. Other end and other end. Now let's just compile and save. And we need to do another trick on the second sequence here. Let me just get this open. There we go. Move it here. And once again, we'll need a reference to our other end and our other start. Go and place it there. And this time what we're going to do is we're going to tell it with our parent build here. So once again, get our parent build. We need to check with our conveyor here. So get conveyor build. We're going to get our first item. So we're going to get items, and we will get number 1. And the reason we're doing this is we're going to check whether we want to restart them. So to know that, we need to simply check if it's reached the end. If the first one's reached the end, then that means we can restart. If it hasn't, then none of them have. So we simply do this, and we call, if it does happen, we want to call from here, we want to call items moved to next conveyor. This, and we will be calling the item moved the number 1, and it will restart because in here we tied to setup. So it will do all that for us. Then complete, so go back to setup and we'll do the same thing but with the actual end this time. So plug that in here, this as well, and there we go. So let's just align these up a bit. There we go. So that will do it for this. We just need to now call this once we place our build. So inside of placement, on place build, right here at the end, we want to call setup. I think it's linked, we called it. Yeah, setup linked builds. I apparently left it in pure, so that's the reason. So there we go, it's attached here. And that will set up our linked builds. So now we can go ahead and actually give this a try. So if we press 2, our items appear. If we go on a attach point, it shows itself, but we can't place it. So if okay, I know it. So the reason it can't be placed is because we haven't set up one thing that I needed to add, and that is we need to add to our A builds an actual ignore system. So the reason for that is that when we add the is buildable, we can actually inform it of some items that we want it to ignore. So here we're going to create a new variable. We're going to call here, so promote to variable. It's going to be called actors to ignore. We'll leave it exactly as that. It's a symbol. It's all that it's for. We want it to be exposed on spawn so that it's easier to actually create it. No, sorry, expose on spawn. And I'm just going to look so that I get everything right where we want it, so that we don't have to go through 100 things. So we only use this twice currently, and that is in our update location for our build conveyor. So inside of update location, we are looking at here. Once we hit an attach point, we need it to know that we can ignore that. So to tell it that, we're going to get actors to ignore, and we're going to add to it the actual parent of the other end. So here, get other end, and we want parent build. So get parent build, attach it there, and we're going to perform the same thing on the start. So go all the way over here. Sorry, this one right here. Going to do the same thing. We replace the end with start, not this, but other start. There we go. And that should fix our issue. Let's go and see how that goes. So let's place it, and it does indeed work. And as you can see, the items aren't spawning, but once we place it normally, the items should start spawning. So the reason the items aren't spawning is something I've forgotten, a bit stupid. Inside of Conveyor, so inside of Conveyor where we made our can spawn next item, we told it that if there is no last item, then it shouldn't be allowed to spawn, but that's the opposite. It should be allowed to spawn if there's no last item, because there is nothing on the conveyor. So let's try that again and hope that it works this time. So for some reason, once out of twice, I don't get my attach point spawning, which is strange. So we have one item that spawns, but not a second. So, oh, we have a second, just a lot slower than expected. So why is that? Okay, so I'm back from troubleshooting and I'm completely stupid, but the reason the item was taking so long to spawn is because spawn next, we left it by default, and by default it's 5. But it should be 1, and I didn't think about changing that, so I apologize for that. It should be set to 1, and now if we run it, it should normally work correctly with intervals, etc. that are rather short. There we go, 3 items, 4 items, 5 items, and it should go up to 10, but it should stop here and not spawn anymore. If I press F here, not F, sorry, E, it will remove it, spawn the next one. If I remove the last, it should also spawn one. If I remove the first, they will move forwards to the next one. If I add a new conveyor at the end and place it here, they should continue. Let's try and fix that as well. I solved the issue as well for that, so that's just a mistake on my part. I also forgot. We need to connect these to the items moved. So this is in the setup linked builds. It's at the second part of the sequence, and for both of these, not just the top, but both. We need to connect them like that. Let's just make it a bit clearer by having these pass above. There we go. So it's just because apparently I forgot, but we need to call it from the next conveyor in this case, where the item is being moved to. So we can remove that. So that was just a print while I was testing. And that should be everything. If we play, we can attach a conveyor here, it'll move. And once it reaches the end, it will stop all of them. If we attach a new conveyor, they'll all keep going again. And once they reach the end, they will stop. If we pick up an item on one conveyor, it will let the other ones behind know. If we pick one that seems ambiguous in between the middle, it will move as well. If, let's say, we add a longer conveyor here, just make it a bit wider, even though it shouldn't be allowed to do that, it's fine. Just to check that if we connect it while they're still moving, they still keep going. So they do. And let's see if they keep going when they reach the middle part. They know there's the next part and they can keep going. And obviously the reason there's so few is because we set this to only take in 10. So we removed some and that's why we have this many left. So let's, well, I guess that's how it works. Let's try and make a nice and long one to run a proper test and we can call it a day. So if we go here, we can add a nice long one all the way here to make it go back around back here. Let's place it there. Pull another one all the way back again, and the items indeed do move properly. They're all going down, no problem whatsoever. They keep moving, and I guess that's what we were looking for. Let's have a view from the top of the conveyor working. So thank you for watching. Oh, so we do have a little bit of an issue. What happened here? Why did they get stuck? Let's have a look. So I figured out what the issue was. The issue is on how the actual placement of the conveyor works and not at all about the conveyor system. Ironically, what happened was when I spawned my actual conveyor here, and we can recreate the same problem even without having it come at the end, is what I did is instead of doing this, I had it be very close, but it actually was making a different line that wasn't connected to this one. So like right here, if I place it, it's not going to work because it's actually two separate pieces here. We have this conveyor and we have this conveyor, but they're not connected one another because I missed the attach point. So it's a coincidence, if you want, as why that happened. But it also allowed me to recognize some other issues. So this, it does work. It doesn't connect perfectly between and sync up the different items and sends them across one another with no issues. One thing I noticed that could be an issue later, although it's not an issue, but more of a bit of a bug. Inside of conveyors in the spawn next item, the setup linked builds, we need to check if this is valid first, because there are scenarios where it is empty, and if it is empty, then we get a bug. So what we'll do here is we will check is not empty. We'll add a boolean, or a branch, sorry. And if it is not empty, then we can save it to true. If it isn't, so we do the same here. And if this is true, so it's not empty, that means we can place and call all the rest of the logic with no problem. So, because that's just an issue if you were to go and place, for instance, two conveyor belts like this now, you would have that problem. It would call an error. But it doesn't if we do this. So normally everything is good, because in A item we forgot something rather crucial, and that is to actually set the item up anywhere, because we never actually do that. So I need to set that up very quickly. So in event begin play, we want to get our data asset. We want to get static mesh. And we want to set static mesh because I completely forgot to do that. And without that, there is no visual. So might as well add that. It does kind of make it all work, doesn't it? So one last time to see if it all works. Let's drag this out. And now we actually have the iron ore coming out first instead of the ingots. And let's pull this across a bit more. And it's going. Now let's steal 2 of these. That way, and we'll steal 1 here. So once these 20 come out, it should turn into the, there we go, into the actual ingots. Let's go and wait and see if these... And with that, this extra long video is complete, and you now have items that move along a conveyor, can be picked up from the conveyor, will stop by themselves, will be spawned from, well, any construct or any item you want to make from the buildings class. I hope you enjoyed, and I will see you in the next video. I'm not sure if I'm going to be doing a part 5 to this right away, but it might be in maybe a few more weeks. I'm not sure what I want to do yet, but let me know if there's anything you want to see, and I will see you in the next video. Goodbye.